In question number 6 in the extra class book, there is a particle called P, and on this particle it has been given that there are two forces which act. One of them is a completely known force, and that force is called F1 bar. Now F1 bar's magnitude is given to be 10 newtons and its direction is 60 degrees above this horizontal line which passes through P. So this is of course the sub question A which we are doing. The second force acting on P apart from F1 bar is F2 bar, and its direction is shown to be vertically downward in the figure like this, F2 bar. And part A further says that the acceleration of particle P is given to be in the rightward direction, and with this data we are supposed to find what is the force F2 bar. So that's the first part of question A. Now to do this question, we recognize Newton's second law states that the force on the particle, the net force on the particle, so that's the resultant force, equals the mass times the acceleration. And since m is the mass, it's going to be greater than 0, which would mean that the force, the net force and the particle's acceleration would both have the same direction. Now if the acceleration is rightward as mentioned in the question, then the resultant force is necessarily rightwards. So in short, the question when restated says the following: if the resultant of F1 bar and F2 bar is in the rightward direction, then what would be this force F2 bar? What would be its magnitude? Now if you look at F1 bar, you can resolve it into a rightward and an upward component. To make things clear, I'll draw an x-axis and a y-axis in the conventional way. So the x-axis is rightward positive, the y-axis is upward positive, in which case F1 bar can be expressed as 10 newtons multiplied by cos 60 degrees I cap plus 10 newtons multiplied by sine of 60 degrees times j cap, this many newtons. So F1 bar, in other words, is going to be 5 I cap plus 5 root 3 j cap newtons. And it has been just stated that F1 bar plus F2 bar, the resultant force, must be in the rightward direction. But what is F1 bar plus F2 bar? It's 5 I cap plus 5 root 3 j cap plus, now F2 bar is in the downward direction. In other words, it can be expressed as, you take the modulus of F2 bar and simply multiply it by the vector in the downward direction, the unit vector, which is minus j cap. So I'll just express it in some other way: 5 I cap plus 5 root 3 j cap minus mod F2 bar times j cap is F1 bar plus F2 bar. Remember, it has been indirectly mentioned that this F1 bar plus F2 bar is in the rightward direction. We just proved it over here. Now if it's in the rightward direction, it cannot have a non-zero y component, or in other words, it's a y component. The y component of F1 bar plus F2 bar must be equal to 0 bar. So these two terms ought to cancel, and the only way that they can cancel is if mod F2 bar equals 5 root 3 newtons. And that's exactly what we wanted to find. We wanted to find F2 bar. In fact, we have found its magnitude. and we already know that it's in the downward direction, so F2 bar is minus 5 root 3 j cap newtons. That's the answer of the first part of sub question A. Now in the second part of the same sub question, it has been mentioned that the magnitude of the acceleration of that particle is 2.5 meters per second square, and we want to find what is the mass of the particle. Now in other words, the acceleration is given to be 2.5 I cap meters per second square. I attached I cap because I know that the acceleration is in the rightward direction in this figure. So the acceleration, if it is 2.5 I cap, you're supposed to find what is the mass of the particle. Now let's see. The total force, the resultant force on the particle is mass times acceleration. The resultant force is given by F1 bar plus F2 bar, and we have set up the expression over here, but we did note that this term and this term actually cancel. So what is the net force? The net force is 5 I cap. It is this thing which I have written, 5 I cap newtons on the left hand side. That's equal to the mass times the acceleration is 2.5 I cap meters per second square. Now I equate the coefficients of I cap on the left side and on the right side. They must be equal, of course. So what I get is 5 newtons equals mass times 2.5 meters per second square. You take the 2.5 to the left hand side, and the units are all in SI, so obviously the mass will turn out to be in kilograms. So mass turns out to be 5 by 2.5, and that's 2 kilograms. So the answer of part A, the first answer, is the force F2 bar is minus 5 root 3 j cap newtons, and the mass of the particle is 2 kilograms. Now let's go to part B of the same question. So this part, you start with the same particle. So you have this particle whose mass we just calculated in the previous part to be 2 kilograms, but some other conditions on the question, they undergo a change. Let's read it. Imagine that in another experiment, none of the forces was initially acting on the particle P, and the particle P was at rest. So the particle is at rest. At t equal to 0, the force F1 bar starts to act, and simultaneously a second force F bar of magnitude 10 root 3 newtons also starts to act on P. And when these two forces act on P, it's given that P moves in the rightward direction. So obviously the resultant of these two forces, the first one is F1 bar, the same force of part A, and the second force is an unknown force. It's not F2 bar, that's not mentioned in part B, so it's not there. There is a completely new force, F bar, and the only thing known about F bar is the magnitude. It's given to be 10 root 3 newtons, and we do not know what is the direction of F bar. However, these two forces, they add, and the resultant of these two forces produces a rightward velocity in particle P, which is initially at rest. So that means that the acceleration of particle P must be rightward, because the velocity changes in the rightward direction. And since the acceleration is rightward, the force, the resultant force must have a direction which is rightward. Now let me draw F1 bar first of all. F1 bar is the original force in part A, so we know it's 10 newtons, and we know that this angle is 60 degrees. Now to this, if we add another force F bar, then the resultant is definitely towards the right. The question asks us to find what is the direction of F bar, and it specifically asks us to find the direction by a method which involves geometrical method, and also by an algebraic method. So I'll first demonstrate by the geometrical method, in which I apply the triangle law. As you know, the triangle law is a law used to add two vectors, in this case two forces, to get their resultant. So F1 bar will be one side of the triangle, F bar will be the second side of the triangle, and the third side is going to be the resultant, which is F1 bar plus F bar, and which we know to be towards the right. So according to the triangle law, I have to, if I start by drawing F1 bar, I already have it in the picture, then F bar is to be drawn from the end point, that is the end of F1 bar, so from the point marked in red. Now I have to draw this particular vector F bar such that it must end on this dotted line. Why is that so? Because the resultant, let's say that I draw the two vectors in this way. So this vector is F bar and the first one is F1 bar. Now the resultant of these two is the third side drawn in this way, and we can see that the resultant is towards the right. That would not be the case if F bar would have ended somewhere over here, in which case resultant would not have been to rightwards, it would have been rightwards and downwards. So I need to draw the vector F bar in such a way that it ends on that dotted line. Now how do I draw that vector exactly by geometry? So we first remember that the magnitude of F bar is given to be 10 root 3 newtons. So let's imagine a certain geometrical construction. You need not actually do it, you can draw a rough diagram. So imagine that you have drawn this force, namely F1 bar, and you have to now draw the second force, which is F bar. So I'll just rub this out. We have yet to draw it. The force F bar has a magnitude of 10 root 3 newtons. Now this is 10 newtons, and 10 root 3 is going to be larger than that, because root 3 is larger than 1. In other words, I must draw a force F bar whose magnitude is larger than 10 newtons, larger than the black force which I have shown over here. And what other things do I know about F bar? I know that it must start at this red dot and it must end on the dotted horizontal line. Now obviously in geometrical construction, I think you must have learned in school, I think, that the way to draw this is to take a compass, geometrical compass, put the metal tip of the compass on this red dot, select a radius of 10 root 3 newtons. So of course it would mean that if 1 newton equals 1 centimeter, then the radius must be 10 root 3 centimeters, and so on. So if I have a radius of 10 root 3 newtons, I place the metal tip of the compass at the red point and I draw an arc, so something like this, whose center is this point and whose radius is 10 root 3 newtons. So I'll just complete the arc like that, and we see that this arc, it cuts the horizontal dotted line in 2 points. One of them I'll call it point Q, the other one is point R, and accordingly I can draw two possible vectors f bar such that they end on the dotted line. One of them is this vector, so I can even name it. If this point I call S, then SQ bar is the first possibility, and the second possibility is the vector which goes from S to R. So these are possible choices of F bar. Both of them have a magnitude of 10 root 3 newtons. So I'll just write on top 10 root 3 newtons. The same goes for the other vector too, and both of them end on the dotted line. So we have narrowed down our choice for F bar to two choices. One of them is SQ bar and the other one is SR bar. Now both of them give a resultant force which is along the dotted line. So if I choose SQ bar, then I get a resultant PQ bar which is on the dotted line, and if I choose SR bar to be F bar, then also the resultant is on the dotted line, but it is in the leftward direction. Now the acceleration of the particle is towards the right, which would mean that this particular choice of F bar is ruled out because it yields a leftward force, and this choice is the correct choice because it yields a resultant force which is rightward. Now what I have done is to clean up the figure, and essentially I've got a certain triangle. So the black side, the red side and the blue side are the three sides of the triangle, and also the triangle is unique. If I ask somebody to draw this triangle, he'll get a unique triangle. Everybody will get the same triangle. You can't draw this triangle in any other way. And if that is the case, if you can think of even a single triangle whose left hand, or whose this side is 10 newtons, this side is 10 root 3 newtons, and this angle is 60 degrees, if you can think of even a single triangle like that, then of course that must be the same as this triangle because it's a unique triangle. So you already know that a 30 60 90 triangle, probably you must have guessed it. If I have these angles, I'm just writing these three angles, 30 60 90. Now in a 30 60 90 triangle, if this side is 10 newtons, it will happen that this side is 10 root 3 newtons. Obviously tan 60, 10 root 3 by 10, it's root 3, so that's correct. So you do know of a triangle which fulfills these particular characteristics, has these characteristics, and naturally it means that this must be a 30 60 90 triangle too. So this angle is 30 degrees, and it means that the direction of F bar, which we have to find incidentally in part B, the direction of F bar is 30 degrees below the rightward horizontal. Now what happens if you do not think of this 30 60 90 triangle? It may not strike you, let's say. So is there any other way to find this particular angle? So the angle is theta. Both of these angles, this one and this one, are equal, we want to find them, and I've called them theta. So of course you can do it if you know the sine rule of trigonometry. If you apply the sine rule, you get, take any one side, let's take 10 newtons, divided by the sine of the opposite angle, so divide by sine theta, equals, take any other side, take 10 root 3 newtons, divided by the sine of the opposite angle, and the opposite angle is 60 degrees. So what I get is sine theta equals, now this 10 newtons will cancel, so this leaves me root 3 there. So sine 60 degrees equals root 3, sorry, sine theta equals sine 60 degrees sine of 60 degrees multiplied by, or rather divided by, root 3. Now that's root 3 by 2. Okay, root 3 by 2 divided by root 3, and simplified it becomes half. Now sine theta is half. So one possibility, of course, I'll write it here, theta is 30 degrees. Of course it could be 150 degrees, but 150 degrees is not correct because the figure clearly shows that theta must be an angle which is acute. So I just rub out this 150 degrees, and this is exactly the answer that we got by recognizing that it must be a 30, 60, 90 triangle. So what is my final answer? F bar's direction is like that, 30 degrees below the rightward horizontal. Now the question also asks us to find the direction of F bar by another method, namely an algebraic method. So I'll just show it below this. I'll start by drawing the basic diagram. Again, part B, there is this particle of mass 2 kilograms, and there is a force F1 bar directed 60 degrees above the rightward horizontal like this. It's a 10 Newton force, and there is a second force F bar whose magnitude is given to be 10 root 3 newtons, and we do not know the direction, but we do know that the resultant of these two forces is in the rightward direction. We know that F1 bar plus F bar is in the rightward direction. Now let me express F1 bar. I've already done it earlier in terms of I cap and j cap. So 10 cos 60, so 5 I cap plus 10 sin 60, so 5 root 3 j cap. And similarly F bar, I can express it as Fx I cap plus Fy j cap. And since I know that when I add F1 bar and F bar, only the x components will survive this addition, they will remain, and the y components will cancel. So what it effectively means is that this Fy must be minus 5 root 3 because it has to cancel with this term. So I'll just rewrite that second term as minus 5 root 3 j cap newtons. Both of them are forces, they are in newtons. So if I can just find Fx, then this force F bar is fully defined, and if it's fully defined, that is in magnitude as well as direction, and what is asked is the direction, so I can easily answer the question if I know Fx. I need one equation because I've got one unknown Fx, and the equation of course is mod F bar is 10 root 3 newtons, which would mean that square root of Fx square plus 5 root 3 the whole square, that's the mod of F bar, that's 10 root 3 newtons, square both sides, Fx square plus 25, okay, 5 root 3 the whole square equals, on the other side I've got 100 into 3 which is 300, so Fx square plus 25 into 3 is 75, that's 300, take 75 to the other side, it becomes 300 minus 75, which is 200. Just simplify it, sorry, 225. Take the square root on both sides. I get Fx equals plus or minus 15 newtons. So I can write F bar. First of all, I'll write it nominally with both roots. I'll reject one of them shortly. So plus or minus 15 I cap minus 5 root 3 j cap newtons must be F bar. Now if you add F1 bar and F bar as desired, this term and this term cancel. We want that to happen, and what remains is the addition of this term and this term. However, let's imagine that I select the minus sign, minus 15 I cap. Then the addition of 5 I cap and minus 15 I cap is negative. In fact, it is minus 10 I cap. In other words, the resultant force is going to be leftward if I select the minus sign. Now this is wrong, because we have just showed that the resultant force must be rightward because the acceleration is rightward, and that's why I reject the minus sign. Now this doesn't happen, this contradiction doesn't arise if I select the plus sign. So this is an algebraic method to find F bar. I'll just write it over here. F bar seems to be equal to 15 I cap minus 5 root 3 j cap newtons. And once we have defined the force as a vector, once we have the components, we can easily find what is the direction of F bar by the standard procedure. So I first write the x component, that is 15 I cap, so that's 15 newtons, and the second component is in the downward direction because of this minus sign, it's 5 root 3 newtons. And if I complete this particular parallelogram, then the diagonal, this diagonal is going to be F bar. Now I do require this angle, I'll call it theta, and just apply ordinary school trigonometry. Tan theta is 5 root 3 newtons divided by 15 newtons, so that's, this cancels, it gives 3 here, this cancels, it gives root 3, it's 1 upon root 3, and the only acceptable answer for theta is 30 degrees. And the reason why this is the only acceptable answer is the following. Trigonometrically, if I add 180 degrees to this, to 30 degrees, I still get the same tan. So theta can be 30 plus 180, which is 210 degrees. However, if I just think a bit about this 210 degrees, clearly if theta is 210 degrees, we are talking about theta below the rightward direction. So you'll have to go back like this and even beyond this line, so the direction of F bar would be something like this. Now that contradicts this figure completely, where the direction of F bar is rightward and downward, and this figure is correct incidentally. Why is it correct? Because we have derived that the force F bar has a positive x component 15 and a negative y component, which is minus 5 root 3, and therefore this figure must be right. It has a rightward component and a downward component, and therefore the general direction of F bar must be correct like this. It can't be like this, and that's why 210 degrees is ruled out. The only correct answer is, the only acceptable answer is 30 degrees, and that's exactly the answer that we got by the geometrical method. Now finally we have to find what is the acceleration of the particle. Now for that we are going to apply Newton's second law, which is the resultant force is the mass times the acceleration, which can be rewritten as the acceleration is the resultant force divided by the mass. The mass is of course given to be 2 kilograms, or rather it was derived to be 2 kilograms in the previous in the previous sub question. So it's going to be F bar resultant divided by 2 kilograms. Now let's try to figure out what is F bar resultant. You can do it by any of these two methods. In the first method, in part B, now you know that this triangle which we have got in front of us is a 30, 60, 90 triangle, and the resultant is this blue vector PQ bar. How much is it going to be? It's a 30, 60, 90 triangle. This angle we know to be 30 degrees now. This angle is the right angle. So just observing this clearly, this must be a 20 Newton. It's double of this 20 Newton force. And of course the other way to find the resultant force is from the second method, in which when I add this 5i cap with this 15i cap, I get what is the resultant force, because this one is going to cancel with this one in the addition. So once again the resultant force is the same, that is 20 I cap newtons. I just substitute it over here, 20 I cap newtons divided by 2 kilograms, and the answer turns out to be 10 I cap meters per second square. So the acceleration of the particle is 10 meters per second square towards the right. Now we can go to part C of question number 6. Before seeing or viewing this screencast, I suggest that you try and do the problem yourself, and you can check your answers from the following. The answers of question C are: number 1, F bar has 2 and only 2 possible directions when the magnitude of F bar fulfills the following relation: mod of F bar is greater than 5 root 3 newtons. So 5 root 3 is less than F is less than 10 newtons. The second one, that is, there is the condition for there to be one and only one possible direction for F bar is either, so there are two possibilities, mod of F bar is equal to 5 root 3 newtons, or mod of F bar is greater than or equal to 10 newtons. And the third possibility is, or rather the third question, what is the condition for there to be no possible direction for mod of F bar? Mod of F bar should be less than 5 root 3 newtons. Now if you are stuck, I suggest that you do it by the geometrical method, by the triangle law. Now naturally part D follows from part C. The minimum possible magnitude of F bar, so that you can get at least one direction of F bar to fulfill the conditions in question A and question B. In other words, what is mod of F bar minimum, so that the acceleration of particle P is towards the right. So you just choose the minimum value among all these. Of course here you don't look at it because it's the condition for F bar to have no direction, no possible direction. So naturally the minimum value is going to be 5 root 3 newtons. Now if you're stuck in doing this, if you don't know how to proceed, then I suggest that you try the geometrical method of using the triangle law of vector addition. And of course if you can't do it still, then you can, and even if you do it, you please do follow the screencast which is going to start now. The solution of part C is as follows. So we start by drawing the particle P and the force F1 bar. It's 10 newtons in magnitude and the direction is 60 degrees above the rightward horizontal. Now if you want to draw F bar in such a way that the addition of F1 bar and F bar is to be rightward, Remember, that's the condition uh, for the particle's acceleration to be rightwards. We want this addition to be rightwards. So by the triangle law, I must draw a vector f bar starting over here from this dot and ending on the dotted line. So for example, like this, or it could be even like this. So for example, if you decide that you want the magnitude of f bar to be this, let's say, I'll rub out the other forces. You don't want these two. So you've got a force f bar of a certain magnitude, and you do seem to get a rightward resultant force like this. There's no doubt about that. Now supposing that this magnitude was given to you, I don't know what it is. It seems to be greater than 10 newtons at least. The length of the red arrow seems to be greater than the black arrow. So if this magnitude was greater, it was given to you, and you are asked to find the direction of the red force so that the resultant is rightwards, then how would you have done it by the triangle law? You would have taken your compass, geometrical compass, put the metal tip over here, and you would have taken the radius to be whatever magnitude of f bar is given to you. You would have then drawn a circular arc like this, and you see that the circular arc in this case cuts the horizontal line in two places. So initially you would have thought that there are two possibilities for f bar. One of them is this force, and the second is force like this. Now in the case of the second possibility, the resultant of f1 bar and f bar is leftwards, and so that's ruled out. In other words, you just discard this one, and you end up with only one possible direction for f bar, and that is the direction given in the figure, the rightward downward direction. Now see, you seem to have initially got two possibilities for f bar, and one of them was ruled out because that force ended somewhere to the left of the particle. Now will this always happen, and what are the conditions for this to happen? In other words, what are the conditions for us to get exactly one possible direction for f bar? So to begin with, we see that this force, the red force f bar, seems to be larger than 10 newtons. So does it mean that if the force is larger than 10 newtons, I will always initially get two possible directions for f bar, and then I will always rule out one of them for the same reason? Let's see. Let's try increasing this force even larger, to a value which is even larger than this. So the initial value, that is the mod of f bar given to you, is even larger than this, and you have to try and draw the possible forces f bar. So you put the metal tip of the compass at the red dot, you draw an even larger arc, meaning with a larger radius. So what would happen is your arc would be something like this. It would be concentric to the older arc because the center is the same. And yes, you seem once again to get two possibilities, at least initially. One of the possible f bars is this one, and the second one, which is ruled out for the same reason, is this one, because the resultant of f1 bar and f bar is towards the left. It is this one. We don't want a leftward force, so that's ruled out. So that's why the leftward possibility is immediately ruled out. It seems that if you go on increasing mod f bar, you seem to end up with exactly one particular f bar, and one of them is ruled out. Now what happens if I decrease it? Let's say that I draw an arc of a smaller radius. So mod of f bar is less now, it is decreased. I draw an arc like this. The radius is of course mod of f bar. The center of this arc is the red dot. So I still seem to get one intersection point between the arc and the horizontal line over here to the right of P, and one to the left. So still I have exactly one f bar. Of course I'm talking about this force. And does this process continue forever? See, I get exactly one f bar when I increase mod f bar, but when I decrease mod f bar there is a limit. In other words, there is a lower limit to the magnitude of f bar, and let's say that I decrease mod f bar. When I reach that lower limit, and if I go beyond that lower limit, that is lower than the lower limit, then all this logic, it suddenly won't work. Now what is that lower limit? So just imagine that you keep on decreasing the radius of this arc like this. The center is still the same, the red dot. So what happens is you still get one intersection point, this one, to the right of the particle and one to the left. So initially you get two forces, two particular f bars, and one of them is ruled out. But you can see that as the radius of the circular arc decreases, finally what's going to happen at one stage is that when the radius of the circular arc is 10 newtons itself, what happens is the circular arc passes through the particle over here, and on the other side of course it does cut the horizontal line in one point over here, and you can see that if I do draw that particular force f bar corresponding to this situation, then I do get one intersection point to the right of the particle. In other words, the resultant force in that case would be rightwards as needed. However, if I choose the other point, which is at P itself in this case, then my f bar is exactly equal in magnitude but opposite to f1 bar. It's the negative of f1 bar, and the resultant is 0 bar. Now here is a situation where the resultant force isn't towards the right, in fact it's 0 bar, and so that particular possibility is ruled out. But you still have one possible answer. So if you think, you'll realize that this particular answer is the acceptable answer because the resultant is towards the right, and this one is the rejected answer because the resultant is not towards the right. Now what happens if you decrease f bar, its modulus that is, even further? So just a bit I'll decrease it. You see now that the circular arc actually cuts the dotted line in 2 points, and both of these points lie to the right of the particle. So this is one point and that's the other point, and suddenly I end up with a situation where I get two possible directions for f bar. One of them is that and the other one is that. You see of course that both of these, each of these red arrows, they will effectively give a resultant which is towards the right. Of course the resultant has a lower magnitude in case of the second arrow and a higher magnitude in case of the first arrow, but that doesn't matter. The resultant is rightwards, and therefore both of these arrows are equally acceptable. Now what does that leave us with? It means that for large values of mod f bar, you seem to get one direction for f bar which is acceptable, and as you go on decreasing mod f bar right up till the point when mod f bar is equal to 10 newtons, in other words, as long as mod f bar is larger than or equal to 10 newtons, you get exactly one possible direction for f bar, and that is what I meant when I gave this part of the answer over here. So one possible condition is mod f bar is greater than or equal to 10 newtons. When you see that this condition is fulfilled, you automatically conclude that there is exactly one direction for f bar, so that the acceleration of the particle is rightward. Now just think over what led us to believe that the lower limit is 10 newtons. Just go through that thing again. See, when I reached a radius of 10 newtons, then what happens is the circular arc cuts the dotted horizontal line still in 2 points, but one of the points of intersection is the particle itself. And when I decrease the radius further, then I came to this situation, so what seemed to happen is the circular arc, talking about this one, it intersects the dotted line in 2 points, and both of these points are to the right hand side of point P, and that's why what happened is I got two possible forces, two possibilities for f bar. One of them is this one and the second one is this one, because either of these possible f bars results in a resultant force f1 bar plus f bar in the rightward direction. Now this figure is not very accurate. You see that this force has the same magnitude as this force, so this triangle ought to have been an isosceles triangle. I have not drawn it in a very accurate way, sorry. Yeah, so that triangle ought to have been an isosceles triangle, this one. So anyway, now does it mean that when I will tentatively write something, when f bar is less than 10 newtons, I get exactly two answers for f bar. Is that correct? I do seem to start with that possibility. When I decrease f bar, mod of f bar, to a value lower than 10 newtons, I do seem to get two values of 2 f bars, that is. But this doesn't continue indefinitely. So for example, if I draw a perpendicular from the red dot to the dotted line, then it's easy to prove that this perpendicular distance is 5√3 newtons. You will have to use this particular triangle. It's a right angle triangle, 30, 60, 90 triangle, and the hypotenuse is 10 newtons. So it is this perpendicular distance which is 5 times √3 newtons. Now what happens if I draw an arc of radius 5√3 newtons? So this is the arc that I will get. You will see that suddenly what seems to happen is the arc, it intersects the horizontal dotted line not in 2 points. It was doing that, but when I reduced the circular arc to a radius of 5 root 3 newtons, there is a single point of intersection. So the dotted line is actually tangential to the circular arc. Now that indicates that although this condition is okay to get two answers, but it's not the complete condition. It's also necessary that mod f bar, so and apart from mod f bar being less than 10 newtons, the other condition which must simultaneously be fulfilled to get two answers is mod f bar must be larger than the perpendicular distance, which is 5 root 3 newtons. And that is the motivation behind writing this thing over here. So you see that if this particular condition is fulfilled, that is 5 root 3 newtons is less than mod f bar is less than 10 newtons, then you get exactly two answers for mod f bar. On the other hand, what we have proved earlier is that when mod of f bar is greater than or equal to 10 newtons, we get exactly one answer, because the other answer is ruled out. It gives a resultant of, it gives a leftward resultant. But now we have suddenly come up with another possible condition for us to get exactly one answer for f bar, and that's the condition mod of f bar is exactly equal to 5 root 3 newtons. If you go to the figure, you see the figure, when mod f bar is exactly equal to 5 root 3 newtons, I'm talking about the case where mod of f bar is perpendicular to the dotted line, and in that case, of course, there is one single point of intersection, and you get a resultant force which is rightward. So it's still okay, this resultant force, you want it to be rightward. So I've got another condition for exactly one answer, namely mod f bar is 5 root 3 newtons. Now this process is going to continue. If I draw a circular arc with the same center, that is the red dot, but with a radius even smaller than 5 root 3 newtons, I have something like this or like this, and you can see that this circular arc is not going to cut the dotted line in even a single point, and therefore it is not possible for the resultant of f1 bar and f bar to be rightward, and hence you do not get any answer for f bar which fulfills the given conditions. And that is the motivation behind writing this part of the answer, that is, if mod f bar is less than 5 root 3 newtons, you get no answers or no possible directions for f bar. And of course part D is answered already. What could be the minimum possible magnitude of f bar? What I mean is the minimum possible magnitude of f bar which fulfills the condition of the problem, namely that the resultant must be towards the right. So you can see that if mod of f bar is greater, then of course you do get an answer for f bar. In fact, you get exactly one answer. And if you decrease mod f bar so that it is smaller than 10 newtons, at the same time ensuring that it is larger than 5 root 3 newtons, then too you get an answer. In fact, you get two answers. So the conditions of the question are still being fulfilled, and finally when you reach a value of 5 root 3 newtons for mod f bar, you still manage to get an answer, but this time you get exactly one answer. And when you decrease mod f bar to a value lower than 5 root 3 newtons, then from that point onwards you don't get any answer for f bar at all. In other words, the answer for part D, which is, the question is what could be the minimum possible magnitude of F bar to fulfill the conditions given in the question. Of course, it's going to be 5 root 3 newtons. So that completes the question number 6 in the extra classwork.